later.
That's my job. Some of us will have an exchange semester.
Yeah.
In April or in May.
Okay. Did you get message? Did you get news? Just now?
Yeah.
Ah, congratulations. So you both are gonna be in Frankfurt. Great, congratulations.
Yeah.
Fantastic. That's great news. I'm happy to hear that. I hope you're gonna have a great time.
Yeah. If you have available time, we'd like to have a meeting with you there.
Oh yeah, sure. You can always reach out, send me an email and we'll figure out the time.
I sure think they're in.
Okay. Anybody else from our group coming to Frankfurt soon? You're waiting still on the news? Okay, good. So fingers crossed for all who are still waiting.
Actually,
all right.
I also have received the email for but maybe I'm not go this time.
Okay.
So for another time, so I
You will
will
apply in the future again?
maybe for another, but I just regret that I need to give up the chain. The chain I have just received. So I mean I have just received the chain to go to Germany as another, but I cannot go this time. So
So you are not able to go
yeah.
for other reasons,
Yeah.
or I see. That's
Yeah.
that's too bad. I'm sorry to hear that, but of course, there's always a million reasons to
Yeah.
that factor into this. I totally understand. So okay, let's get going, folks. Okay, so what did we do before the break? What did we achieve so far? And I worked with Tui over the break, so Tui can also run the file notes. So everyone has now the mod file, this mod file, and we all have written, so to say, the general setup. We have written the model equations. We did a little bit of debugging with Owen's great help. We figured out we forgot something. Then we have this steady command, and then we have this stock symbol command. Okay? And when you run this file, let's take a look at the command window output. So the command window output says something like this. It gives us the steady state results. Well, this is R head, this is pi head. Of course, the steady state of a head variable is 0, right? So that's why they have all zeros here. Right? The deviation from steady state is 0 in steady state. And then we are going to get something like this. The matrix covariance is 0. And then the transition functions are this. This is the solution. And then the moments are this. And so there's an issue here. And the issue is the following. You see that there's 0 variances. Variances are all 0. Right? So in other words, this economy, there's nothing that produces fluctuations in this economy. And you can see this here. You see that the zeta, by default, is 0 variance. Okay? So in other words, the zeta is the exogenous shock, has 0 variance. So how can we turn this around and we can have some positive variance? How do we do that? In other words, what's missing from this code still? What is missing from the code? We miss what? No. Shocks. We're missing a shock statement. Okay? We need to tell Dynair between shocks and end, we need to tell Dynair what is the variance of the shock. That's the idea. Okay? So for that, we need to go in here, we need to type in var for variance, zeta, and we need to set this equal to a number. And for now, let's just set this equal to the number 1. I mean, we can, later on, we will change that number, but we need to tell Dynair what's the variance of the shock. Otherwise, Dynair assumes there are no shocks in the model. So when you type in that, and you hit save, and then you run this code, like we run this code, then you're going to start getting impulse responses. Hooray! Right? And you're going to get command window output, and then you see now, there is the variance of the shocks that we typed in. This 1 here is exactly that 1. Okay? So this is where the variance ends up. And then we're going to get the theoretical moments, and now we see some of the variables are going to move around. And we have these correlation patterns and the autocorrelation and so forth. that great? Isn't that amazing? So let me know who has this output, who runs this successfully, who has an error message. Is there somewhere a red, an error message on your computer? So let's see, what is this going on here? Doesn't seem to have finished. Typically you have this, see, there are these two forward triangulars. That means that, so where is this? That's the control. Do control C, control C. There we go. You see? Now you should see a picture. No. So try for you to restart math. You just shut this down and restart it, and then let's see whether you can run it again. Can you do this right away? Are you trying to? So who else has an issue with these impulse responses or this code? Is somebody? Do you have these impulse with an error message? What is the error message saying? Sorry. Okay, you have that, but that looks different.
Yeah.
Okay.
Because I saw this different.
Exactly. So can you go to the parameters?
We need to block one.
Exactly. You have overwritten them. So if you
Yeah.
have to comment this out. There we go. And then you run it. And now you have it. Okay. You have it, Dean. Perfect. Ivy is restarting. Okay. So do you understand that, Dean? Let's wait for a few seconds for Ivy, for her MATLAB to start up, and then we'll see whether we can get this to work here. No, there we go. Excellent, that worked. Okay, good. So first things first, right? We are having impulse responses. And so what are these impulse responses? They show us the government debt to GDP ratio, SB, in deviation from steady state, and they show us tau, where tau is that that tax, right? That's the tax that we have, okay? And but they don't show us other responses, right? We don't get, we only so that's the first thing to notice, right? We get, the model has, look what the model has. The model has Rn pi, SB, and tau, right? And, but we only get shown two. What's the reason for that? Well, Dynere by default doesn't plot variables that are approximately zero. It's just like if a variable is zero, approximately, doesn't move, then Dynere doesn't display those impulse responses, unless we force Dynere to do that. Okay? And the way to do this is to force Dynere to plot all the variables, is to add one more option into the stock simuum, and that says plot IRF underscore threshold equal to 0. So this option now says I want to have all the impulse responses even though they are 0 exactly or approximately 0. So that's the idea. Now you save this and then you run it. And then what you're going to get is an error message. Must be different. Okay, I have to go online to check out this command correctly. Dynere. I made a mistake most likely in the wait a second. It should work. Let's see where is it. Plot IRF threshold. Try one thing here. Okay, I have to go to the Dynere website. So let's go to dynere.org. And then on dynere.org, I'm going into the documentation and I'm plotting and typing in plot IRF threshold. And I don't get this. Interesting. Okay, so then we have to search for stock_simul and then hit enter. And we go into the stock_simul and then we look at all the options that stock_simul gives us. Okay, I made a typing mistake. I used plot IRF threshold, but the correct command is IRF plot threshold. Bloody mistake. Okay. You know what? Anyway, I'm not going to make that show. So it should be IRF plot threshold. There we go. Okay, so the correct, and then here you do 0. Okay. You do 0. So it's going to be IRF plot threshold. And now we're going to run this code. And now what you should get is, you should get 4 graphs with the, because we have 4 variables, right? The model has Rn, the model has pi, and the model has Sb as a variable, and it has tau. So those are going to be exactly our 4 variables that we have. Okay? Those are going to be our 4 variables. Okay? Now what we see is, now we're going to get towards the fiscally led or monetary led parameter cases. So this is now the monetary led parameter cases. Right? We commented those out. So we are working with phi equal to 2 and gamma equal to 2. And now we see what's going to happen here with the non-interest rate, with inflation, with the debt to GDP ratio, and with tau. And the first thing to notice is that inflation moves, right? But the paper told us with the monetary led, inflation doesn't move, right? I mean, isn't that weird? So we go into the paper that we showed you again. Right? We go into the impulse responses of the paper, and we learn that in the monetary led impulse responses, it's 0. It doesn't move. But when you are now looking into the MATLAB, right? Take a look what MATLAB produces for us. Inflation moves. So did we make a mistake now, or what? What's going on? What's the problem? What is the problem? What's that? The units. IV, UI, right? In macro, units are everything. So let's zoom in. What are the units? This is 10 to the minus 17. This is numerically 0. I mean, this is like 0.000000000 something. Okay, so this is 0. This is just numerical noise. It's not. I mean, it's not even a fraction of a basis point on inflation. Okay? So this is actually, that's the reason, because this is numerical noise. That's why Daniel doesn't plot it, because it is actually 0. In other words, if you were to put this on the same scale as tau, for instance, this would be 0 right here. That's scary. And the same is true for the normal interest rate. Does somebody understand why the normal interest rate is 0? The central bank doesn't move the interest rate because of what? Because of the Taylor rule. The Taylor rule says if inflation moves, the interest rate is going to move. Well, if the inflation rate doesn't move, the interest rate is going to move. That's all consistent. And so in the monetary-led environment, when the tax moves, right, then the only thing is that the debt to GDP ratio moves. But it's going to be stationary, we're going to come back to 0 over periods of time. Okay, so we figured that you always have to interpret these units correctly. Now, there's one conceptual problem with these impulse responses, right? And the conceptual issue with these impulse responses is that when you go to the paper, right, they are always considering a text cut, right? So they're looking at the zeta falling, right? It's a text cut that pushes up inflation or not. Okay? So we want a cut in taxes. That's what we want in our codes. But here, what do we get? We're getting a hike in taxes. This is tau. What we have implemented so far, we're actually studying a hike in taxes. So what did we do there? Why do we get that? What's the issue here? Did this last week with the monetary policy shock? That's just a hit. Can remember when we did the Montemosi shock? What did we do there? Yeah, it was the sign thing, exactly, right? So when you're typing in model equations into Diner, the way Diner is coded, it always considers a positive innovation to, you know, an exogenous variable by default. Okay, so the way the codes are written, Diner always goes and says, you know, there is a shock, zeta here. That zeta is a shock, and the way Diner is written, the deep routines, they always consider when you want to look at impulse responses, there's a positive innovation to zeta. But of course, we want a negative innovation to zeta. So now we could go deep into the formulas or into the computer codes of Diner and change stuff there. But what is the easiest way to do this? How did we do this with the Montemosi shock? Exactly, right? So the way to do this is we're literally just going to flip the sign here in this equation, right? Because it's all linear, then when this thing goes up, when we have a negative sign on top there, then we're going to have a form tau. That's it. So that's why we're going to have a negative here. And then we're going to do save. So the only thing is we flip that minus sign, and then we're going to run this code, and then we're going to get this picture. Okay? So now we're getting close. So we're having a cut in the tax rate that is debt financed, so government debt goes up as a response to that. This is a debt financed tax cut. And what we see is that the interest rate and inflation are going to be flatlined. That's the blue line, is the monetary-led environment. The central bank keeps inflation in check, right? The central bank keeps inflation unchanged. And the government finances the tax cut today with more debt. But then going forward, and this is where we see the tau flipping. Going forward, the government needs to raise taxes in the future to run down government debt. It's exactly the idea that we developed, that when it's monetary led, you know, the fiscal authority can cut taxes today, but it has to increase taxes in the future. And it does so to bring back the government debt. I mean, we derived this, that was the whole purpose of the derivations that we did in the beginning of the morning, right? This was exactly this, you know, this intuition building business here, that when we are in the monetary-led environment, like right here, when we did the monetary-led environment, the idea was, well, we cut the tax now, then when the price level can't change, you know, then future taxes have to increase to balance that government budget intertemporally. Okay? So we worked this out that under the monetary leadership, that the tax cut, the government needs to raise taxes in the future to come back with government debt. Okay? Great. Of course.
Why is first 0.01?
Yeah.
It has to be 1%.
So let's be careful here. Just go back to the code. Okay. So this is a deep 1%. This is a 1 percentage point cut in tau, and the debt to GDP ratio goes up by 1 percentage point. But we come back to the units in a little bit. I want to make sure that we interpret the units correctly. I'll get back to that. I want to do one more thing before that, though. Okay. So we have this all set up now that we understand. Yeah. Monetary led, you cut the tax today, you have to raise taxes tomorrow, right? So how do these impulse responses now look like for the fiscally led regime? Okay? So that's why we can go into our computer codes now and we can comment out lines 10 and 11, right? You just comment those out. And we can uncomment lines 14 and 15. So now that's going to be the opposite, so to say, or the other case. So we're going to save, and then we're going to run. And then we're going to get a new impulse response. It's going to look like this. And what I'm going to do is, I'm going to arrange my computer screen to have both sets of impulse responses next to each other. So the left-hand plot is the monetary-led responses. That's figure number 3. And the right-hand side is the fiscally-led responses. That's the right-hand side there. Okay. So first question to everyone. Do you have these two plots? The old monetary-led and the new fiscally-led. Who has those impulse responses? Does it work? How about you guys here? 2? Are you? Do you? It all works. And 3. 1.
Yeah, no, let me try.
Just a little. Does it work? Okay, perfect. Yes, very good.
Can you delete those 2 percentage points here? And now add 2 percentage cents from those. So that's like to comment out, right? So the code isn't using these parameter values, now the code is using these parameter values. That's good. Can you run it? Okay, so now we haven't put in the red. Can you go downstairs? Can you type in here? Can you type in here after the 10, do comma, write in IRF plot threshold. Plot underscore threshold is equal to 0. And then you run it. You know you haven't saved that. You just save it. Control S for save. There we go. Now you run it. There we go. Now you get it. Okay?
Perfect. All right, everybody has that. So now we can directly compare the 2 different sets of impulse responses, right? Under the fiscally led environment now we have the tables are turned results, right? Now we have the cut and tau today, look at that, right? But in the future, the government doesn't change the tax at all, right? It does not, increase the tax to bring down government debt. And what happens is that inflation now has to do the job, and inflation goes up now, and inflates away the government debt, okay, in real terms. So that the real value of government debt, this is the nominal debt to GDP ratio, right? This is the nominal debt to GDP ratio. So this is, and you see that nominal debt to GDP ratio is unchanged because B goes up and the price level go up by 1 to 1. So the real, debt to value of debt is unchanged. It's exactly the intuition that we try to develop as well. Before this morning, when we did the intuition environment, right, which is this one here. So here we considered this intertemporal government budget constraint with the fiscally led environment. And if you have, we did this with a permanent cut, right? But you can have just a transitory cut, and all these things are constant. Well, then the price level needs to jump. That's the idea. Wonderful. And so we basically get qualitatively the results from the paper. Are there any questions? We have to work a little more, but this is basically the intuition and the quantitative results that are, so to say, in the background. So some of you may say, wait a second, Matthias, but why is SB unchanged? And we need to work a little more on that. Okay. But before we want to do that, I want to do one more thing. Namely, I want to show you where, when you are in so to say, looking at these. Yesterday, we had this square box here. There. No. I'm looking for a place where we, there, right? So when we discuss these monetary and fiscal mixes, we developed this kind of square where we said, look, there are 2 rational expectations equilibria of particular types, they're off diagonal, but the stars, that's not a rational expectation equilibrium. How can you detect this in Diner? That's what I want to show you next. Okay? And it's so Diner is going to tell you whether you have found a unique rational expectations equilibrium that's stationary. And the way to do this is you have to type in one more command into your code. And this is after the steady command, you're typing in check semicolon. So you're typing in check semicolon. And with that, we're going to get the following. We're going to run this, so we're going to hit the up arrow, okay, and we're going to run it again. And we're going to get the same impulse responses, so nothing's going to change except there is now some command window output that we can look at, okay, which is this one. This is the command window output, and this check command produces this. Produces this a little bit cryptic output. And what does it do? It basically checks whether there is a rational expectations equilibrium. And that those are the so-called Blanchard and Kahn conditions. Have you heard about the Blanchard-Kahn conditions?
Yeah.
Min the other day was talking about the Blanchard-Kahn conditions. And whenever it says the rank condition is verified, the Blanchard-Kahn conditions are satisfied. Meaning you have a unique rational expectations equilibrium. So that's the key. So now what you can do is, that's the fiscally led parameters, right? With the fiscally led, everything is good. You don't need to change this, and you can if you like. Okay? Let me go to the monetary led parameters, and go here, with the 2 and with the 20, okay? And let me compute the solution for that one more time, and see whether the Blanchard-Kahn conditions are satisfied. And there we see, right, we're going to have that, we have, again, the rank condition is verified for that. So in those two equilibria, the fiscal and the monetary-led mix, we are having a unique rational expectations equilibrium. Now let's do a little bit of a fun exercise here, and let's try to can we, figure out a combination of parameters where we would maybe end up either here or there. And let's see what Daniel is doing when we try these. That's the key. Okay, let's just try to let's play a little bit with that. So you guys tell me what parameter values could let's try to get the active case. Active monetary, active fiscal policy. How would I need to change, maybe the parameters here to get active? Right now, right, this is active passive. This is active monetary, and this is passive fiscal, right? That's how you have to interpret these numbers. So if you want to get active, what would we need to set to? Gamma. We want to set gamma maybe to 0, right? Okay, let's do that. So let's set gamma to 0, put a semicolon in there. I always keep my original parameter value like this. And now let's run this and let's see what happens. And the air is gonna it screams at us. There we go. So now we're gonna get this new output from Danier. And that's exactly, this set. Now it says the rank condition isn't verified, still cryptic. But then Danier gives us more. It says the Blanchard-Kahn conditions are not satisfied. In particular, we have no stable equilibrium. So we have an explosive equilibrium. Precisely the idea is that when you are setting the debt stabilization parameter, right? This is the debt stabilization parameter. If the government doesn't stabilize debt is going to go and explode. And when debt is going to go and explode, you're going to have a non-stable equilibrium. That's it. Isn't that beautiful? Yeah. So Danier actually tells us everything that we discussed in theory already. Okay. So let's go back and let's do maybe the other case was passive, right? The other weird equilibrium would be passive. So let's go back here to the original parameter value 20. That's the original parameter value 20. And how can we now get passive? How would we get now a parameter combination that's passive? 0 and 20, exactly, right? So let's set this to 0 and 20, and let's rerun this now. And so this would mean that we have passive. And now we get this error message from Danier. the conditions aren't satisfied. And what now we have is we have indeterminacy. Now we are in a situation when there is the sunspot equilibria, the non-fundamental fluctuations. It's Ivy thinking inflation is going to be high, and exposed the economy is going to see high inflation. So Dainera tells us that as well. Super good. So in other words, let's go back here to the slides. Right? What we just learned is, for instance, and then of course if you change parameters, but if you go back to these slides, we just learned that active is often explosive dynamics. Okay, those are often the explosive dynamics, and the passive are often indeterminacy. Okay? That's what, so to say, we just learned from that. Okay. Very, very good, folks. So what else are we going to do here? Let's go back here. So once you're finished with copying or writing, please, very important, everyone, go back and change this back to 2 and 20. Okay. Go back and change that to the number 2 and the number 20. So what's the game plan for the next steps? Well, I told you that so we have essentially succeeded now in getting all the things that we want. In terms of the impulse responses, like what we learned quantitatively from this paper, we are able to implement this quantitatively. But what I also want to talk with you about is, in the appendix of the paper, they have these impulse responses. So they show this. And there is this thing that Hui was talking about in terms of the units. And secondly, these impulse responses, they still look a little different than the impulse responses that we see in our graphs. And so that's something that we need to work on a little bit. We need to work on and making sure, because I want to get to this graph with you, that we are able to produce exactly this graph. So for instance, we have a public debt here, but we have the debt to GDP ratio in our model. And so forth. So we need to, we need to think a little harder. How can we? Now this is B. This is the level of debt. This is not the debt to GDP ratio. So I want to teach you, or I want to learn with you, how can we, get additional variables to this rate. Right? Because right now this is the debt to GDP ratio, but we want to plot the level of debt rather than the debt to GDP ratio. How can we do that? So that's going to be the next little task that we're supposed to do. Okay? To plot the debt to GDP ratio. Let's go back to the task that we have. The task that we took up on is to implement the model in Dainera and to do the analysis on the monetary and fiscally led equilibrium. There we go. Right? So the task that we took up on is that we want to, we have done the, we have done the impulse responses and the coding. But now I want to also get the level of debt and the price level as additional objects in my impulse responses. Okay? So how can we do that? So in other words, how can we develop now the impulse responses for the level of debt as well as the price level? How would we be able to do that? Something going on today with the beamer or so. Going off and on. level of inflation, how did we get the level of the price level, and how did we get the debt level? So let's start with the price level. What do we need to add to the code to display the price level? How would you do that? How would you do this? Well, that's there. Okay. So we have implemented this model, right? We have implemented these 4 equations. That's what we already have in the code. But rather than, but I want to know what is the price level. How can we do that? The price level. I want to look at not only the rate of inflation, but I want to look at the price level. How can we compute the price level? Think about it. How can we compute the price level? Let me give you a hint. Somebody tell me, what is the definition of the rate of inflation in this model? What's the definition of the... Exactly, right? So let's consider, the definition of the inflation rate. Of inflation. What is that? That is pi t was the ratio of pt divided by pt minus 1, right? That's the definition of the inflation of inflation in this model. That's how we have defined inflation in this model. Inflation is the gross inflation rate, and it's the ratio of the price levels. So in case you are wondering, we did exactly use that derivative. So when we derived the consumer-Euler equation, go back here, when we derived the consumer-Euler equation, we made exactly use of that relationship, right? So that is pi t is equal to pt over pt minus 1. And when we derived the consumer-Euler equation here, we used exactly that notation there. Pt plus 1 is pt over pt. So if we, so a good starting point then is, if you want to plot or calculate what's the implied price level, you're just going to start from the definition equation of inflation. What would you do next? How would you now use this equation in the computer code, perhaps? What would you need to do next? You will need to... The computer code says everything log linearized, right? This is the level of inflation. You need to log linearize this equation. So log linearize this equation. Log linearize. What? So what do we get from this log linearized equations? Well, that's going to be pi t head is equal to pt head minus pt minus 1 head, right? That's just the log linearized equation for the inflation rate. And now we can just add that equation to our code. It's going to add one more equation and one more variable. That's it. Okay. So you can actually now, once you have typed that equation into Diner, hit a button. Diner is going to give you the path for the price level. So that's how you can get more equations into your code and study more variables if you want. Does that make sense? Yeah. Okay, let's do that. So let's go to Diner and let's type in the equation for the price level and inflation into our Diner code. Let's do this. So now you guys tell me, how are you doing this? How would you like to do this? You guys tell me what I'm supposed to type now. What would be the first thing to do to add that equation to the code?
To add the endogenous variables.
Perfect, right? We need to go and we need to add another endogenous variable, and that's the price level, right? So we can call that maybe uppercase P for the price level. That's going to be pi head, right? It's pi head, but that's the price level, right? Next, what is next? The equation in the model, exactly, right? So let me go here, line 22, and now we just type in pi head is equal to P head minus P head minus 1. There we go. So we've just typed in that equation. We have typed in the log linear definition of inflation, and that's going to give us a new variable. Now we have 5 equations, not 4, in 5 unknowns, with the price level being the 5th equation. So far so good? So hit and save this, and then you run it, and then you should get an impulse response that should kind of look like this. So now we have one extra subplot that displays the trajectory of the price level. Who has that trajectory of the price level? Who has an error message? Who has an error message? Juan, do you have an error
I
message?
don't know.
Not yet. Okay, take your time. Let's wait a minute, Juan, for you, and and then I'm gonna ask whether it's successful in generating.
Yeah, em cho chị tự do luôn mà.
All right. Let's see one. What is the issue?
So I'm just not follow the process because I need to reply the scholarship office.
Oh, I see. Okay.
I reject so.
Oh, I see. Okay.
So sorry. I
No,
can
it's
follow
okay.
up. No worry. I can.
Okay, now let's do this together. That's important. So, first of all, you want to go upstairs to the definition of the variables. So if you go up, you want to add a capital P right there. And then you want to go to your equations. And there. And then you want to write just down here, you just want to write in pi is equal to uppercase P minus 1. And then semicolon. Don't forget the semicolon. And that's it. And now you run your code. Let's see what happens. Okay, so there's still an issue there. Now, can you take a look at the parameter values? Yeah, I see. Can you just the parameter values? So can you just do 2 and 20? So delete that percent sign there, and then put a percent sign down here. Okay, perfect. There we go. Okay, so that's it. So
Now, of course, here nothing happens to the price level because this is a 10 to the minus 16. Because, of course, if inflation doesn't move, the price level isn't moving. And that's just, right? But then we can now go to the fiscally led environment. Okay? So we go and we uncomment the phi equal to 0, gamma equal to 0 case, and we put in, percent, we comment out these, at the top. So now we have the fiscally led parameters. And now we run this stuff, and when we run that, we're going to get the following impulse responses. Where we see, right, the rate of inflation goes up by 1%, right? This is 0.01, this is 1%. And then you see you have a permanently elevated price level, which makes perfect sense, right? Inflation goes up once, but then inflation comes back to 0, and that means there's a permanent. This is the inflation hike. And then here, inflation is 0, so the price level doesn't change any longer. So you have a permanent effect on the price level with the fiscally led expansion. With the fiscally led parameter mix, but you see a tax cut, is going to lead to it's going to have the debt to GDP ratio unchanged. It has no change in the nominal interest rate, but it has a run-up in inflation, but it produces a permanently higher price level. So when we go to shop, and we're shopping, we're going to pay permanently more money for the same amount of goods than we used to do in the past. Okay? So that's how you can get the price level response. Okay? Now, let's go then back to our task. Let's go back to our task, field here, right? And here I said, okay, let's not just have the price level, but let's also have the level of government debt. Okay? What is the level of government debt? I want to also plot that level of government debt as an additional variable. I don't want to, plot the debt to GDP ratio, but I want to plot the level of debt. So how could we do that? How could we plot the level of government debt rather than the debt to GDP ratio? Any ideas? Any ideas? It's maybe simpler than you think. Let's do, write the level of debt. Level of debt. consider the definition of the debt to GDP ratio. So the definition of the debt to GDP ratio is SB comma T is equal to, does somebody remember that definition? What was that? That was QT times BT divided by PT times Y, right? That is the debt to GDP ratio. And the debt to GDP ratio is going to move because of three things in this equation. It's going to move because of Q, it's going to move because of B, and it's going to move because of P. And so when you want to interpret why does the debt to GDP ratio move, you need to know what is Q, what is B, and what is P. Okay? Now we know that we can write this as, Q is nothing else than just 1 over Rnt, right? So we know this is equal to Rn comma T PT Y. Okay? So we're going to convert the Q into the normal interest rate. There we go. And then the final step is, of course, folks, you're going to log linearize that equation. You're just going to log linearize this equation. What does log linearizing give? Log linearizing, what does this give? Well, it's going to give you SB comma T head is equal to uppercase BT head minus Rn comma T head minus PT head. That's it. That is the log linearized debt to GDP ratio. And now you stare at that, and you're going to say, wait a second, that's going to give me exactly what I want. It's going to give you the dynamics of the level of government debt. Right? Now, in terms of the code that we have, the code already has the variable SB. And the code already has the variable R. I'm sorry, this should be a lowercase r here. I keep on making that same little mistake there. This is, of course, lowercase RNT head. It's lowercase RNT. So the code already gives us this, the code gives us this, and the code also gives us this by now. So in order to compute B, we're just going to type this equation into our code. And that's going to give us the level of B. Alright? Everybody on board with that? Yeah. So let's do it. Let's do it. So we're going to add one more endogenous variable. It's going to be uppercase B, the level of debt. And then we're going to go to the model equations and we're going to type in SB, we're going to leave out the head, as a thing, is equal to B minus Rn minus P. And then semicolon. That's it. Okay. That's it. And then you're going to save. Oops. By the way, right, if you're typing in your Dynare, sometimes you see a little star popping up there. The star means you haven't saved your file yet. So it's good practice to, once you have a star and before you want to run, I always unconsciously hit Control S for save on my computer. Okay? Or Command, on Mac it's Command S. So if I hit Command and now S, then the star is going to disappear. Okay? It's just going to, you can also just hit the editor button out there, editor button, and then you hit the save button. And then it's the same thing that star disappears. Now you run it. And then once you run it, you're going to get the following impulse responses. So you're going to get these impulse responses. Now let me ask you, who has these impulse responses? Does everybody have these impulse responses? Who has an error message? Nobody? All right, so what do we see here? Well, basically we don't see much. Let me introduce you to another functionality, right? You have these, you can hover over here, and then you have this little hand field. You just click with your cursor on this hand field, and when you do that, you can go into your plot, and you hit the button, you hit your trackpad, and you can move the plot around, okay? And what I want is, I want everybody to do that here, and I want to do that here as well. That's just highlighting the impulse responses. So now, this is the fiscally led equilibrium we see the government cut the taxes, and we don't see any, any change in the tax going forward. We see inflation picked up. We understand this perfectly, right? We have worked very hard today to understand in the fiscally led, inflation is going to eat away part of the debt. What is maybe a surprise to you guys is that the debt to GDP ratio is unchanged. The debt to GDP ratio is unchanged. That may be weird, because you would think, wait a second, the government cuts taxes, it needs to issue more debt to pay for that tax cut, right? It needs to finance that tax cut with more debt. But how come the debt to GDP ratio doesn't move? Well, it's because the numerator of the debt to GDP ratio and the denominator of the debt to GDP ratio moves by the same amount. That's the key. So now, plotting the level of debt, you can now see that the debt goes up and it's going to be permanently elevated. Okay, so the transitory debt tax cut, it's a transitory tax cut, leads to a permanently increase in the debt, in the level of debt. So debt is going to be permanently higher. The Vietnamese government cuts the taxes in your economy. That's going to mean they're going to have permanently more government debt in the economy, in nominal terms. In Vietnamese dong, it's going to be 1 trillion Vietnamese dong in extra debt. But at the same time, because inflation jumps, the price level jumps also by exactly the same 1 trillion Vietnamese dong. So even though you have 1 extra trillion in debt, you're going to have a 1 trillion extra in the price level, and so these two things move 1 to 1. So that's why the debt to GDP ratio doesn't move. That's the key idea. So in the fiscally led equilibrium, with the fiscally led equilibrium, you're going to get that the debt to GDP ratio doesn't change, because the debt is permanently up and the price level is permanently up. And then you see that this produces that the debt to GDP ratio is going to be constant with in a fiscally led environment. And of course, this nominal interest rate doesn't move because the central bank is passive, right? Even though inflation goes up, the central bank doesn't move its interest rate. It's like the central bank is told you're not going to move the interest rate. Okay? That's the passive monetary, active fiscal environment. Any questions to this? All right, is this it? Can we now move on to the partially funded government debt?
Yes.
No. No. Because when we look at these impulse responses, they do look different than the impulse responses that the authors give us in their appendix. These are the impulse responses that the authors give us in the appendix. So there's a glitch here, there's a glitch there. But these are the impulse responses that the authors give us, and maybe it's instructive to maybe consider this. So let's go to the monetary-led environment. Okay. Let's go to the monetary-led environment. And so in other words, let's use the monetary-led parameters. Let's set phi equal to 2 and gamma equal to 20. And let's comment out phi equal to 0 and gamma equal to 0. So let's just comment that out. And let's rerun this code. And let's see how these impulse responses are looking like. So this is the monetary-led economy. And here are the impulse responses. And if you look closely, you'll see, for instance, the debt dynamics look very different in our model, or here, right? This is the debt dynamic. It looks different than the debt dynamic that the authors give us. Okay. We compare that. I'm going to pull. This is the paper. This is what we have implemented so far, and this is what the paper has. And you see that the paper's impulse responses for the level of debt looks different than the linear implementation that we have so far. And also for the primary surplus, look, this one goes down, but then it goes up, and it's more curved, right? This one is like, there's something weird here. So we still lag the exact results that the authors have. Okay? And that's what, again, when we hear the course, and the theme of the course is advanced topics in monetary economics. And I want to bring you to the research frontier. We did that with the macro climate model, right? When we worked on understanding what do people do at the macro climate research frontier. And we're aspiring to do the same with the monetary fiscal interactions, and I think we've gotten far. But part of the game of doing research and trying to follow people is that you need to be able to, when you're saying I want to re-implement the model, that you need to make sure that what you are re-implementing, what we're doing right now, is going to generate the same results that the authors report in their paper or report in their technical appendix. And we are not there yet. So we're missing something. We're missing something. And does somebody have an idea? What do we miss here? What is the missing little piece that we are missing? What is the missing bit? Why these impulse responses here look slightly different than the impulse responses that we have? Why is that? Let me give you a little bit of a hint. It has to do with zeta. What we are doing in the code so far is we're looking at a one-time shock to zeta. There's a one-time shock to zeta. It's a one-time tax cut. If you read their paper, they are considering an autocorrelated tax cut. So they are not assuming this to be a one-time tax cut, but it's a tax cut that follows an AR1 process. And so that's what we are missing in our code. Okay, so we are assuming this is IID, but they are assuming it is an AR1 process with autocorrelation factor 0.5. And that's what we have to do. That's going to be the final step. And then we will be able to get exactly those impulse responses. So now this is going to mean some brain surgery on our codes. Okay? So we need to go into our codes and we need to now think about how can we put in an autocorrelated shock. So we have this zeta here, and that zeta is hitting here, right? But we want the zeta to be autocorrelated, not IID. So how would we actually do that?
One more equation?
Yeah, exactly. We need one more equation. That's absolutely right, one, right? So we and now it's useful now to maybe go and do this from the back, like go backwards. Let's go into this model code here, and what we want is we want to add one equation that says now zeta is equal to an autocorrelation parameter. Let's call that rho times zeta open parenthesis minus 1, like 1.
Yeah.
And then plus, we call that
E.
zeta eps,
Yeah.
for instance.
So we need to set the.
What's that?
So we need the variable.
Yeah, one. That's exactly right. No? So the next thing is, right, so we have now typed in this equation, right, the zeta here, and we have the zeta. Now there's one thing I want you to change. We need to flip this minus sign back to a plus sign,
Yeah.
but flip this plus sign into a negative sign.
Mm.
So just to get these things correct, we're going to flip this back to a plus sign, and we're going to flip this to a negative minus sign there. That's the key, okay? So we have a plus there, and we have a minus sign there. So everyone, add this equation, do this as zeta eps, and have a, go back to the original plus, and then here you're going to flip, because then A again, by default, is always considering a positive shock here. And we want, of course, that zeta falls, and when that zeta falls, the tau is going to fall. That's the idea. Good. And now, 1 is already ahead of everybody here. said there's further changes to be made, so now we have to go upstairs, right? And we have to put in one extra variable, right? Now this zeta is going to become a quote-unquote endogenous variable in this model, right? Because we have added this equation for zeta, this becomes an endogenous variable in the sense of it's driven by an exogenous shock. And now we have here the zeta x, right? This is zeta x. There we go. Zeta x. You guys are becoming pros. You are professionals by now. I'm really happy to learn about that. Okay. So then we need to put the row in here, right? And then what else do we need to do? We need to
Value.
initialize it. Exactly. We need to set a value for this row. And if you read the paper correctly and carefully, you'll learn it's 0.5. Autocorrelation 0.5. Okay. Very, very good, folks. I like it. So what else? Now there's one more little change that we need to do. You scroll down, and where you put the shocks,
Yeah.
this now needs to be zeta underscore EPS. Okay. Sorry. Okay, so it's zeta underscore EPS. All right. So those are. Let me just go through these changes again. So you're putting in an extra zeta in the bar statement. You're naming the shock now as zeta x. You're initializing the autocorrelation coefficient, and you are, as a parameter. And then you are adding this one AR1 coefficient to AR1, and you are changing this f. So I'm going to come around, for in case there's a mistake. Now let me run the code now. Let me run the code, and then the code now looks like this. Or not the code, but I'm saying the impulse responses now look like this. And let me put the paper next to it. So now we can maybe start seeing something. So first of all, if you walk around, who has these pictures? Ivy, perfect. One. Okay. What is the AR message? Oh, I see. So now you need to write the AR1 process. So zeta is equal to rho times zeta minus 1 plus zeta underscore x. Okay, semicolon. You go up and show me the top. That's great. Good.
Ủa bị thiếu gì mà cũng không.
Okay, good. That's fine. Very good. This looks great. So how about you guys here? Dean, how are things? You got the results? Perfect. Go on.
Let's see, what is this? This is line 46.
I make the zeta.
Oh, the semicolon. Yeah, I've forgotten the little semicolon right after the F's. It happens all. That's okay. All right. There we go. That's but wait. Those don't look like the impulse responses that we have. Oh yeah, they are. But we'll get there. No wait, this is different. Can you show me what is the row parameter? Ah.
Yeah, the row.
I see.
But for semi.
Oh, we are in the Montreal. We are in those two parameters. So if you delete that and the other one, and then you go down there and there we go. And now you run your code. There we go. That's it. Perfect.
Perfect. Do it work? Perfect. And you guys have it too as well. So now I think we can start seeing that this dynamic looks similar to this dynamic. So they plot this out for 20 rather than for 10. So we need to increase the number to 20. Okay. But then everything else starts to look relatively similar, right? So that's basically, this one is this one, right? So what they call the primary surplus is the tau, right? That's the primary surplus. So all that looks right. So there's now two little things, and then we can take a break for now. There is we need to go for 20, And then there are still the units, right? There are still the units. These units still look different than our units, okay? So let's fix that. The first is, we want to plot this for 20 periods. Okay? So we want to plot this for, in line 42, we want to plot this for 20 periods. And then the other thing is, we need to scale the size of the shock. The shock that we put in is just way too small. I mean, they are considering a huge shock. That's a 40% drop in the deficit or in the surplus. So this is a huge shock. Okay, that's what they are putting in. So we need to increase the size of our shock. And the trick is, the shock that, it's trial and error. Now you would, instead of 1, you're going to try maybe 10. Or then you're going to do 100. And you're going to try to increase the size of the shock. And when you're putting in 51 squared, so this is trial and error. But if you're putting in 51 squared, that's the size of the shock we need. So it's a big shock. In terms of interpretation. So put in 51 squared and IRF 20, and then you rerun this code, and you're going to get impulse responses from Dynair that are very similar, that are the impulse responses that you see in the paper. Now you see that B, like what they have here, goes to 0.6 and a little above. That's what we see here, and comes back like this. The primary surplus goes to minus 50. That's what this is, and it moves like this. Okay? And the nominal interest rate and inflation are 0. Again, this is 10 to the minus 15 and 10 to the minus 15. And you see there is no change in the price level. That is why the government, in an active monetary, passive fiscal, reduces the government debt over time by generating these surpluses in the future. That's what this line is. And then the final thing is we can, rerun the code now with the fiscally led parameters. Those are these. And so let's do that. Let's go to MATLAB, and now let me do, for the final time of today, go and change the parameters from phi equal 2 to phi equal 0, and then run this code again, and then compare that against the impulse responses that the authors give us. This is now this. Okay. So that is the fiscally led tax cut. Again, this is minus 50. That's what we have here, right? Because it is auto-correlated now, right? So before it was like a one-time jump down. Now it's auto-correlated. So this leaves us going back, auto-correlated. So this is a tax cut over many quarters. And what you see is that inflation goes to 1 in their model, and what you see here is inflation goes to 1 in our model as well. That is the key now. So that checks out against, so to say, these. And then interestingly, they have their debt, they don't have the level of debt. They made a mistake here. They made a mistake. They just didn't plot this in the right way. I think what happened is the following. Look, they have the same units here on these axes, right? But you see that this one starts up north here. So I think there's some typing or plotting issue. You see that the level of debt goes up, under the fiscally led. There, the level of debt goes up, and they don't have that in here in their graph. And then we have this permanent increase in the price level. Okay? So the price level is permanently increased, and the real debt is going to catch up to that hold. Okay. Wait. Yes, I have to check. Yeah, so this is a. Now that I look at this, so maybe they're plotting the debt to GDP ratio here after all. Because look at this. The level of debt goes up, but the debt to GDP ratio goes down. Why does the debt to GDP ratio go down? Well, because the price level jumps on impact, right? The price level jumps on impact, but debt goes up slowly, so the debt to GDP ratio can actually fall. And that is consistent with this plot down here. So that's something we have to discuss tomorrow. Okay? So long story short, I'm 100% this code is correct. It's just the way how we map our results into the office's results. What is important for you to understand is that we have now put together a piece of code that replicates these impulse responses as well as these impulse responses. Okay? And you see, it took us a little bit of effort, and we'll come back to that tomorrow. In doing so, right, we started from a white piece of code, and it took us a little bit of effort in, so to say, learning how to put these, things in. And at the end of the day, we get exactly the impulse responses that the authors have. We have to get back to the level versus debt to GDP ratio interpretations tomorrow. What we're going to do tomorrow in the first half of our course is we're going to learn how to put in this partially unfunded business into the code. So we are going to work for the first 45 minutes or so on what are these impulse responses? How can you do this unfunded and funded fiscal shock? Okay? And then the last hour of our course tomorrow, which is going to be the last hour of the entire course, is then we're going to do a little bit of an overview. What else does this paper show? But it's going to be more an overview type thing. We're not going to go in detail as much as detail. But by tomorrow, say 10:45, you guys will have a complete kind of set of code that produces these impulse responses, including the funded and partially unfunded government debt. That's the plan for tomorrow. Any questions? Great, everyone. I think we all earned a break. So you guys have a great rest of the day. I'm looking forward to seeing you then tomorrow for our final 2 lectures then. Okay? Thank you for today and have a great afternoon. Thank you. Okay. I'm going to upload my code to Moodle. Okay, so I'm going to upload this model.mod code. And I'm going to do this right away. I'm going to upload this to our Moodle board, so you have this as a live coding, in case you want to, cross-check and double-check and so forth. All right.